You're driving a 2,500 kilogram car at a constant speed of 14 meters per second along a wet but straight level road. As you approach an intersection, the traffic light turns red, you slam on the brakes, the car's wheels lock, the tires begin skidding, and the car slides to a halt at 25 meters. What is the coefficient of kinetic friction between your tires and the wet road? So, let's see here. We know the mass of the car, 2,500 kilograms. Okay. VI is 14 meters per second, and it goes 25 meters before it stops. So the displacement will be 25 meters. And then we know that when it comes to a stop, 0 meters per second will be the velocity. Ultimately, we want to find the coefficient of kinetic friction, right? And we know to get that, we need both normal force and the value of kinetic friction. So let's look at the free body diagram for the car. FG is down, so that's going to be 2,500 times 9.80. So if we calculate that, 94. So 2,500 times 9.8 gives us 24,500 newtons. And then that is going to be our normal force. 24,500 newtons. Okay. The car's going that way. So once he slams on the brakes, the kinetic friction kicks in and it begins to push him back that way. There's not going to be any force going that way because he's just going that way because of his own inertia. Okay. Now we need to get this in order to be able to calculate mu k. We know that this causes the acceleration, so we would use Newton's second law for that, equals ma. And we're only going to look at the x forces, the forces in the x direction, because the y ones are balanced. So in the x direction, the force of kinetic friction equals ma. Okay. Now the question is, are we able to get a in order to get friction so we can calculate mu k? And we have our velocities and our displacement. So 14 meters per second to 0 through a distance of 25 meters. So that means we can use our third kinematics equation and rearrange it for a. So we'll do 0 equals 14 squared plus 2a times 25. So we get an acceleration for this of, let's see here, 14 squared. Negative 3.92 meters per second squared. Now that we have that, we can find our kinetic friction. So kinetic friction will equal 2,500 times negative 3.92. So negative 9,800 newtons. And so that's our kinetic friction force, negative 9,800. And now we could solve for mu k. So mu k, just going to rearrange this now, would be kinetic friction over normal. So that's 9,800 newtons over 24,500 newtons. Newtons cancels, and so you do your division and get 0.400.